Hi everyone, welcome to our Scotch STEM podcast. Today we are here with Dr Hayden Tronnolone from Flinders University. I'll pass it over to Josh for our first question today.
Now, we have done some research and found out a lot about your publications, with titles like Diffusion Limited Growth of Microbial Colonies and Extensional and Surface Tension Driven Fluid Flows in Microstructure Optical Fiber Fabrication. From what I can grasp, you do research as an applied mathematician in fluid mechanics, mathematical biology, and mathematics education. Could you help us to unpack your areas of research?
Yeah, absolutely. And thanks for having me along. Great to have a chat here
All
today. So quite a few words to unpack there, I think, as well. I'm an applied mathematician. So the nice thing is I really love is that I get to do maths, but I get to use it to understand a whole heap of real-world problems. So you were talking about the extensional and surface tension-driven flows. This was some stuff that I was doing when I was doing my PhD. So it's looking at a problem in fluid mechanics, and it started with some people in physics who wanted to make a new type of optical fiber. And it was this really weird process where they would take a rod of glass, imagine a rod about 30 centimeters long, and they put a really complicated pattern of holes along the length. They would heat it up and pull it, and you could take this 30 centimetre-ish rod and pull it up to maybe 1 kilometre long. So radical change, absolutely. The thing is they would try and hope that those holes along the length stayed about the same dimensions and position. And of course, it's not really going to happen. You imagine if when it's heated up, it's a liquid, it's going to deform, the surface tension pulls it. So we got to come in as mathematicians and say, well, we can write down some equations that describe how that changes. And if we can, say, figure out how you go from the start to the end, one day we could go the other direction too. If you know what you want at the end, what might you want at the start? So a whole heap of really interesting maths there, and even some maths that you would see in, say, year 12. We use some complex numbers, derivatives and things like that to write down these equations and do that. And it's a huge problem, and I was very fortunate to do some work on this as well. But that process, so that was the fluid mechanics side of things there.
Yeah, and that's very interesting. And also shows how math is so essential to other areas like physics, how you do need those equations in order to figure out what will happen and to construct hypotheses, for instance.
Yeah, absolutely. And I think it's kind of an unseen thing that, we probably all suspect that there's a bit of maths in physics, but this was even experimental physics. And we got to come in as mathematicians and talk to people in labs. It's a weird process because you actually sort of speak different languages. Sometimes you think you're saying the same word, but they have really different meanings. I've done some work in biology as well, you were mentioning before, and that's an even weirder experience because sometimes what you think you mean, in terms of a model in biology, a model might be like a really simple plant or some cells, and where in maths we're going, we can make a model. We're thinking some equations, and they're thinking this little petri dish, something like that as well. So it's that nice thing though where you do get to talk and figure things out and come together.
Being an applied mathematician is a fairly unknown career, especially for school students. So what inspired you to pursue a career in applied mathematics?
Yeah, that's a great question. It's and I've had to answer this question at so many parties, and you should see the looks you get like that. I feel like in a way I almost stumbled into this. When I was at school, I certainly didn't think of applied mathematician as a job, but it's one I'm really glad that I got to have, and probably not many people thinking about that. I finished school and I was just interested in maths, and I thought it would be nice to do something in that. I had a lot of other ideas as well, but by good fortune, I ended up saying I'll go to university and study some maths. And I tried out lots of different things. And I got really interested into that applied side of things. Like I said, because I liked learning about different things, I found that doing applied maths meant I could do maths that I like, but then I get to learn about all those other things that, say, I didn't get to learn about, the fluids, the physics, the biology. So that's kind of what attracted me to doing it. So then as I went through, I did some further study, an honours degree and a PhD like that, and just kept sort of going down that path. It was that attraction to just learning about things and getting to do maths
Yeah.
Yeah, and I think that's also a good point that a lot of people think that math is purely like something you do in school and it's all equations, but really it can be applied to a lot of different areas, and that's one of the great things about being an applied mathematician.
Definitely. I mean, look, don't get me wrong, there's lots of equations and we do love them as well.
Yeah.
But having that meaning behind the equations. And it's an interesting challenge. If you do just say a pure maths type of thing, you know, you can play around with the equations and do whatever you want. In applied maths, you have this funny bit at the end where you can think your equations are great and your solutions are great, and it doesn't match what the real world tells you.
Yeah.
It's completely wrong. You've got to go back and figure it out. So you have that extra challenge that I think is really interesting.
Yeah, cool. Now, the International Day of Maths is on the 14th of March, next week, and the theme for Maths Day in 2025 is Mathematics, Art and Creativity. Can you describe what that theme means to you?
Yeah, absolutely. And look, happy International Maths Day to you both as well, and whoever's listening.
Yeah.
It's a great question again. I think the first thing that often might pop into your head, you think of maths and art, and you know you might see interesting graphs and pictures. People draw things called fractals.
Yeah.
So immediately, I think that's often where we go to when we think of maths and art. But there's actually something else that I often think about too, and it's some of that creative thinking that you get to do in maths and the problem solving. To me, that's actually where the creativity is.
Yeah.
So it's that feeling when you come across a problem and you've got no idea what to do, and you sit around for days, and then one time you're on the bus and the answer comes to you, and then you know it's that feeling.
Yeah.
Yeah.
And that's the creative side. And I think sometimes we're not often very good as mathematicians as well of really communicating that.
Yeah.
Yeah.
We love telling you what was the answer. You know, oh, here's this problem, that's how you do it. And it feels very done. You know, the answer's in the back of the textbook.
Yeah.
Whereas some point in history, someone has sat down and come up with the definitions and the processes.
Yeah.
And that's really where the sort of the edge of maths is right now. Someone out there thinking about these things and thinking about it creatively.
Yeah.
With yourself having a doctorate, what was the most challenging part of your PhD journey?
I think I could probably talk for a long time about some challenging parts of doing that. I think the hardest thing with doing a PhD is just spending so much time on one problem.
Yeah.
And it's something you go through from say in school you might do some research projects, to university where they get a bit longer, an honours year, a master's. By the time you get to a PhD, we're thinking about 3 years.
Yeah.
3 years is optimistic. I don't worry. I went straight through that deadline. It tends to be you kind of finish when you think you finished.
Yeah.
So to me the biggest challenges are that some days you come in and, like we were talking about before, you haven't had that creativity yet, and you're just stuck, and you have nothing else to do because this is it. You're working on this one big thing, so it's that feeling of, okay, when I don't know what to do, what do I do now?
Yeah.
But I think we can sometimes get a little bit of a taste of that as in our maths classes as well, and we're maybe not working on a 3-year project or anything, but it's just one problem and you get stuck, and then that's the time you start to think, oh, maybe I'll just give up, maybe I'll disconnect. So the challenge is, how do you not do that? How do you figure out what to do next? How do you find the motivation around that?
Yeah. And that is a really good point. But the world is ever changing, with more advances in technology and sustainability being introduced monthly. What are some emerging fields where applied math plays a crucial role?
I kind of want to say everything.
Yeah.
I think the harder challenge is find a field where maths isn't going to play a big role. I was recently at an applied maths conference, and one of the presentations I got to saw that really stuck with me was people doing maths around changing the energy grid. So we hear a lot about climate change and the need to change the way we produce energy, and there's mathematicians out there thinking about what this actually means.
Yeah.
Really interesting questions like, maybe where should we put a battery in the suburbs? Where do we think in the future people are going to live? How will people have electric vehicles, and what times will they plug those in? So people sitting down, writing down equations to describe this, figuring out what they mean, and then advising governments, councils, how we overcome these challenges. Lots of other areas though as well. You know, look, we're on the other side. Can I say optimistically of a pandemic?
Yeah.
But thinking about how much maths there was around the planning and that, and again, quite invisible. But you know, everything we were doing, there were mathematicians predicting where things were going, and they haven't stopped. They're thinking about what did we learn, and how can we be better prepared for things like that in the future as well.
Yeah, and that also raises a good point that applied mathematics is a really versatile career. And if you want to get into applied mathematics and be an applied mathematician, there's a lot of people who need applied maths in order to create new technologies, to make change. So I think it's going to be a really key career moving forward. So yeah.
You sort of touched on it a little bit earlier, but for those students interested, could you describe the pathway to get into applied mathematics?
Yeah, and I think there's maybe two sides to this. So I say I'm on a bit of the extreme end, where I'm very fortunate. I just get to do maths all the time, and you know, I call myself an applied mathematician, and that's the job. And as we sort of discussed, you know, I did an undergraduate degree at university and then some further study, and then moved on into some research areas doing applied maths. So to me, if that's one type of applied mathematician, you can go down that route. But the thing is, I think there's lots of people who perhaps wouldn't call themselves a mathematician out there, but I think they are actually an applied mathematician. People in all areas of science who maybe they work in a lab and they're collecting some data, or maybe they're working in SA water and they're trying to predict where people are going to be needing, you know, water connections. I think you can be an applied mathematician in almost anything you do. I often talk to people and try to tell them, I think you're whatever you are, and you're a mathematician. Right? So that's the beauty of applied maths. It's whatever you do, you can find something and you can apply some maths to it. I think the one of my favourite examples of all time is I once got to talk to a business who had all of their prices written down, and they'd forgotten what the original prices were. They only had the price plus GST. And they were feeling really disappointed that we're going to have to go and figure this all out again. And I could tell them how you could actually go back the other direction and get the original. And you know, it sounds so mundane, but it's like those little things that you can do everywhere. You know, if you can describe it with an equation, you can solve it and figure it out with some maths.
And I know a lot of people don't like math in school, but for those who love math, no matter what career you enter, you will need math. And it's great to have people like you who know so much about how to apply that to, like, as you said, like businesses and prices, and even like SA Water, and showing how the government also needs applied math. It really shows how prevalent the need for it is.
Look, absolutely. And I would say to anyone coming through school at the moment, the more maths you can do, the better it is. You might not yet see where it's going to crop up, but it's going to be everywhere. But also, if you are that person, if maths is just really exciting for you and there's always some people around, do feel like that's something that you can do. Don't feel like I like maths, but I have to do engineering. Engineering's great, don't get me wrong. That's fine, but you can stick with maths. Maths is a career. You probably won't ever find a job advertising for mathematician. But there are so many jobs out there where they know they need mathematicians, they just don't know the words to say it, and they say modeler and analyst and data scientist, but it all really means maths. So there's spots out there, and I really encourage anyone, if maths is what you love, come and do some more math study after school.
Absolutely. Well, thank you so much for doing this interview with us. It's been great, honestly, to learn more about applied mathematics and learn more about your journey. So,
thanks so much for having me along. I'd love to talk about maths anytime.
Thank you.
Thank you.